Inspired by Eric's suitcase, I was going to throw these at people, but probably I shouldn't. This is biochar, and I'm going to talk a little bit about biochar. It's a bit like charcoal. It's a bit like activated carbon. It's a bit like a lot of things, but it's not magic, I promise you. Okay, I got a question for you. Who watched the Toronto Blue Jays play baseball last weekend? Everybody put up your hand. Great. Did that have any effect on your business? Probably not. Maybe if you're in a suite somewhere. Okay, second question. Who watched the budget yesterday? Okay, a couple people. That's good, yeah. Interesting parallel, because that for sure is going to affect your life. I was in Ottawa the last couple of days, listening and watching and seeing what was going to happen. I'm David Martin, and I'm the Executive Vice President at Carbon Lock Tech. And we are in the business of converting organics into this material, biochar. And we also are in the business of putting this into mine tailings ponds. So I'll talk a little bit about, excuse me, a little bit about that. I have a cold just evolving, so pardon me. The main pitch of this is, remember this number, $100 million. So I'm going to tell you guys how to make $100 million. We'll see how that goes. Why and how? We are going to accelerate mine recovery and rehabilitation. The goal is to take that 50-year, 75-year, 100-year obligation and shrink it down to 25 years or less. How? Plants, on the left-hand side, you can see, did all the hard work for us. They've done all the work absorbing carbon dioxide from the atmosphere. Plants themselves, plants turn into food, food goes into us, forest residue. All of these things on the left are sources of organic materials. Our clients take those organic materials, which comes in the form of biomass, and they put them into a reactor that we make now and our partners will make in the future. What goes in there? Anything. Organic food, waste, green bin, blue bin, wood pallets, anything at all. And that's our specialty, is putting almost anything into this reactor and getting valuable biochar at the back end. This carbon-intense biomass material here has got all kinds of incredible properties built into it, and we change those properties through this process, and we create biocarbon, biochar, and bio-oil. Two uses of that in mines: tailings effluent ponds treatment, so we can absorb all the toxins and the metals that exist in your ponds and in your water streams. And then we sink that down to the bottom of your pond for 1,000-year permanence, and now you have carbon dioxide sequestration for a very, very long time. What else happens is you have a better environment. So when you take organics out of the world, you don't have smell, you don't have leachate, you don't have landfill problems, you don't have a lot of challenges that we see. You might also not have as many fires. So if you take forest residue, then you've got a couple of opportunities there. So it's a multi-purpose benefit for a whole bunch of different people. Filtering clean water, and then we also can enhance soil and remediate it quicker so the animals will come back and enjoy the property. So you heard me say CDR credits. Anybody know what a carbon dioxide removal credit is? Okay, I didn't until I got into this business. And then someone told me that someone will give me $500 for a ton that they don't actually get. So there's no transfer of material. Microsoft has spent $300 million buying essentially nothing on the voluntary carbon markets. Sounds crazy, sounds a bit niche-y, but statistics will tell you that this is an incredibly fast-growing market. Why? Because they feel guilty. Basically, that's what it's all about, voluntary carbon markets. So on the left, you can see all kinds of people who have been buying carbon dioxide removal credits. They come in various prices and sizes and capabilities. Some of them are worth $1,000 a ton. Some of them are worth nothing if you just dig a hole and put it in the ground. So that's a carbon dioxide removal credit. Carbon Lock Tech has an agreement with Shopify for 300 of those credits. It's a starting point. We won that. But the big money is actually not in carbon dioxide removal credits. It's, as I said, in mines and treating mines. So what's the problem? Probably lots of you know what the problem is with mines and recovery. High remediation costs. And it goes on for what feels like ever. 25 years, 30 years, 50 years, 100 years. It's hard to believe that people put on their balance sheet and their income statements things that look that far into advance, but they have no choice. Limitations of conventional methods. They put in lime treatment to change the pH. There's a bunch of sort of temporary things, but nothing is really that permanent. Nothing really does what you need to do. And many of them kind of piss off the community and the neighbors. Like, you don't really want to be releasing water that's going to hurt people. So you need to treat it better, and you need to treat it for a long time. And the soils all around there get contaminated. So what are we going to do? We're going to quickly and permanently and affordably, at an incredible scale, lock up the organics from the community, from the forests, and put it into the mine with all the metals that you didn't want to end up trickling over. So this is what it looks like. This is an example of some experimentation that we've done with a couple of mining companies. Lime is a traditional treatment material. It changes the pH of the water, and then the water will absorb CO2, and it coagulates, does all kinds of neat things. We use this as a comparison because it's a well-known material. Biocarbon or biochar does similar things, but much better, much quicker, and permanently. The picture in the middle is the standard water treatment guy photo with yucky stuff on the left and good-looking stuff on the right. The yucky stuff on the left came from a mine in Flin Flon, and on the right, single pass across this material, and it looks pretty good. So this material in particular is made from what we call cattails here, but scientifically it's typha. So typha, cattails combined with organic material from a landfill creates this material, creates that material. It's quite cheap, and it's very, very effective. Key benefits, you can see them on the side. Enhanced metal removal, if you want to get the stuff out of the water, it's the quickest and the best way to do it. You don't have any sludge at all. There's no generated sludge, so you don't have to worry about this material. It's locked down in the bottom. Scaling, if you know how water is treated and you know what happens in these processes, you know the scale forms all the time because of the hard minerals. Getting water back, earlier on we heard about what was the water use cycle, and they said in the ablation, the HSP ablation thing, no more extra water. That's great. We actually return water faster than any other technology to use in your mine. And so that's one of the distinct advantages, and also bringing soils back to life as quickly as possible. No chemistry, nothing gets poured in anywhere, and then you have to worry about it a couple hundred years from now. So we make biochar, and the question is, how do we make biochar? There's lots of people who've been doing it in what we call the artisanal area, which is making biochar from wood in your backyard, and then you put it in your soil and your plants grow better. There's lots of that happening around the world. Generally, we're professionalizing it, and in our case, we focused on using multiple feedstocks, and that helps reduce the risk, and it also makes it possible to deploy this everywhere in the world. We are not taking food away from people. We say that we're after food, so food waste and organic waste that come from that. In the reactor, which you can kind of see in the right-hand corner, it's a 3-stage reactor with extremely precise controls. And that's one of our specialties. We got some IP I'll talk about in just a minute. It's programmable, which means that depending on what you put into it, you can program it to put out what you want. And in the case of mining, you want this material with a high surface area, lots of big pores, very reactive, and a certain density so that it slowly sinks down into the pond, picking up the metals as it goes. So, interesting characteristics that we can program into the reactor to give you whatever characteristics you want for that biochar. You may know that it also goes into concrete and asphalt and all kinds of other applications. We may do that in the future, but right now we want to get paid to take the organic waste. Then we'll treat it, and we'll get paid to take the biochar, and then across the top is this miracle of carbon dioxide removal credits. But are we going to be around long enough to make a mine happy? This is a common question I get. I've been involved in, 50 startups around the world, and everybody wonders, are you going to be there 5 years from now when it matters the most? And the answer is yes, because we got intellectual property. We heard earlier about 60 patents pending and 27 filed. We're in the same boat. Lots of intellectual property, both published and not published. Know-how you keep secret. Patents on the biochar production and the biochar use. And therefore, we can license our technology to a whole bunch of different people to do different things with the technology. And that's one of our advantages. You can see that we're a little early by some standards, a technology readiness level 7, becoming 8 in the spring when we do our first pilot project in southern Manitoba. The biochar itself has been explored by a number of companies, Concrete, Lafarge, now Amrise, mining companies, asphalt companies. A whole bunch of people are exploring uses of it, so we're pretty well along the path with a few of those. And then in particular, this idea of soil enhancement as peat replacement. So that's a very niche sounding industry, but it's incredibly large. So this is what we're doing. We're moving our technology from 7 to 8 and then to 9 in the next year. And we're doing that with money that comes from friends of ours. So we heard earlier a couple of people talking about raising money. We are just finishing what we call the pre-seed round. For those of you who don't know, a pre-seed round should be read as pre-revenue, which means you don't make any money yet, you only spend it. That tends to be the pre-seed round. We've had almost $3 million come into the company from strong support from Manitobans in particular, and then we match that with non-dilutive grants and applications. You're welcome to join us on that if you want to. Next summer will be what we call a seed round, and that's the money that you need to get from TRL 8 to 9 and into the field and prove to people that they should join you on your journey. So that'll be next summer, and then there's what the use of proceeds are. In particular, we will build this pilot and then a commercial facility in southern Manitoba to take organic waste from a landfill operated by GFL in the city, and then we will turn it into biochar that will be used in a whole bunch of different applications. After that, for those of you who don't know, comes what's called Series A, and that's the money that you get to go from, hey, that's a cool idea, to, hey, you're making money. So that's the definition of seed round, of A round. And that'll be 2027, 2028, depends on the speed of execution. So this is what we're working on right now and the money that we want it. What would I like you guys to do? So these are the 3 things that we're looking for here today and over the next few months. First one is we want to build a pilot site at a mine in northern Canada-ish to prove that we can remove heavy metals and all other kinds of toxins from your water streams and your ponds. So that's what we want to do. We know we can do it at the lab scale. The question is, can we do it when it's 37 below and all those complications? We also want to prove that this alkalinity enhancement, changing the pH, will change the way the CO2 is absorbed into the water. That's a very complicated chemistry question, which I won't get into, but we're working on that too. And also, we want to prove that communities can enjoy having mines around them because we're helping them with problems that they have, which is waste and smell and all kinds of other things. So that's the first one we're looking for. Second one is, I want to find people here and around here that can prove beyond the shadow of a doubt that this 50-year obligation can be converted to a 25-year. So I've looked at probably 11 sites around the world, and I think that actually might be conservative. But we want mining companies to quietly in the room say, yes, we will change the way we account for the future because you can change the speed at which we rehabilitate mines. So that's the second one. And the third one is we are looking for a capital investment. We want to build a 20,000 ton per year biochar facility in Canada for mines. So that's the third ask. I said $100 million. And everybody's like, what is he talking about? Where's the $100 million? Well, here it is. As an example. So this is Hudbay 777. It's a mine in northern Manitoba, and they have some challenges with it. As you may have read recently, they had to recost it and send into 2132, the termination of the mine. So here's an example of some of the savings. You can see that most of it comes from changing the duration. Yes, you can do water treatment cheaper, and yes, you can recover soils faster, but most of it comes from reducing this obligation from what feels like eternity to a reasonable period of time. And so that's where the 100 million comes from. Frankly, we're told that this is quite conservative from the mining CFOs, but we'll see that once we get into a deeper partnership. $100 million sounds like a lot of money, but to some of you, it's not really that much. But if you take $100 million and you multiply it by 1,000 mines in the world, then the numbers start to get really big. And carbon dioxide removal credits is another $1 trillion business. And waste management at the front end is another $1 trillion business. So now we've got 3 of them that we get to pick from, which is kind of fun and kind of interesting. Oh, but that carbon dioxide removal thing isn't true. Nobody's really doing that. Well, it turns out that 90% of every carbon dioxide removal credit that's been retired, so has been delivered, has been from biochar. So it's proven, it's well known, it's the thing that people do, and we're just going to do it slightly differently and hopefully better. Who's we? Of course, this is a key question. On the far left is Kevin Danner. He's the CEO, Manitoban government kind of guy. He's been working on policy and regulations and actually helped enable some of the carbon markets in Canada. Extremely capable, very kind, nice guy to work with. Not always the case. Second guy from the left is Ryan Zari. He came to us from the direct air capture world. You've seen these big, huge vacuums that suck CO2 out of the air and then through a very complicated process turn into CO2 and put it underground. He came from Squamish, from a direct air capture company. Atish is our head of research, and Atish is here. You can see he put his hand up. He's the guy that knows what this stuff does and where it goes and all of those kinds of characteristics. Decade of experience in it. The last guy, of course, at the end is me. Seasoned engineer, senior leader. I've raised, I've lost track, $350 million for companies around the world. I've worked with 17 venture capital and 2 private equity people. So I think I can add some value, but that's to be determined by the team. We'll see how it goes. So that's the team. And as you know, team is everything, right? You invest in people, you don't invest in technology or products. So this is a pretty important part of us. Okay, back to the $100 million. How do we get there from here? First thing we do is complete our seed round. We're doing that right now, so that's 2025. I'm here looking for a partnership agreement with a mining company to use our biochar to reduce the penalties associated with their water treatment and soil enhancement. And then we will prove to people that we have a custom reactor recipe, we call it, to make the most amazing material according to their specifications. What do you want it to do? How do you want it to do that? So that's what we do after that. Then we will commission our demonstration facility. So that'll start construction in about 3 months. Yes, in the winter in Winnipeg. And by next summer, the end of next summer, it will be kicking out biochar. Then we will get some long-term use agreements with that solid. And there's liquids that come out, bio-oil, which we will put into asphalt, bitumen replacement. Then we will sell these long-term carbon dioxide removal credits for a whole bunch more money, and then we will build this commercial facility at a mine in Canada. So that's the sequence. That's about $100 million worth of spend with a payback of maybe 2 years once this thing is installed. So it's a pretty impressive bit of technology and team, and we'd be happy if you join us. Thank you.
Thank you for the presentation, David. David, I've got 2 questions. My first question is, look, given that mines are located in usually remote locations, and then also given that some of the organic materials that may be used to create the biochar are found near the mines, is the plan to build the reactors in various places, or you plan to build a reactor in one central location and then ship the biochar from there? Then the follow-up question is, how are you powering the reactor? What is the energy source for the reactor?
Sure. The business model for the company is to demonstrate this pathway from municipal organics plus ditchweed, terrible name for it, to an ideal material. We're going to prove that pathway. Then we're going to prove another one. And then people will realize that we're a recipe machine. So our business is actually technology licensing after we've proven a couple of the pathways. Is it mining? Maybe. Are we amazing people that mine tailings ponds? No. Are we amazing at every application? No. We're the people who make the machine for the engineering, the hatch guys left, the EPCs, to build plants for other people in the world, wherever that may be. Peanut husks, whatever it is, wherever you are, whatever feedstock you've got, we're going to have an engine that can convert that to biochar. So that's the business model. It's a multiple pathway IP generating technology company. The answer to your second question is nothing. No energy required at all, except from a cold start. And that you only want to do once every year. So it's fully exothermic. There's way more heat than is required once you get this reaction going. And one of our pieces of intellectual property is taking that heat and dealing with soaking wet, disgusting organic municipal waste, sargassum, phragmites, and all the other ditch weeds, swamp weeds that exist around the world. We take the heat from the reactor and we put it into the pre-processing, and we make these pellets that look like this but aren't soaking wet. And that's one of the super secrets of ours.
You piqued my curiosity with the no energy needed except the cold start. My question is not going to be there, but interested to discuss about it. From my understanding of the presentation, the carbon credit that you're going to generate, you still own them, right? You don't sell them with the product.
There's multiple choices. It's an excellent question because to me it was very peculiar. We can embed or inset the carbon dioxide removal credit in the product, which means that we could sell the biochar for a very different value than if we didn't embed it. So if we get, or if a $500, pick $500 a ton is available, we can take it from the registry and offer it and sell it to other people, or we can embed that in the ton, and then the end user gets the benefit of the carbon sequestration at the bottom of their pond. And what we heard from 2 mining companies is that this is actually a revenue opportunity, right? So in lots of people here, and God bless you, are trying to reduce costs, change the cost profile, reduce expenses. I totally get that. We're bringing a new revenue stream to mining companies, which is carbon sequestration at the bottom of their ponds for 1,000 years. That might also be $1 trillion industry. So we can keep them and sell them to Microsoft, Google, Meta, Shopify, or we can embed them, and then the uptake of our product is much faster.
Thanks for the answer. I'm also a believer that mine sites or old mine sites are carbon sink that needs to be valued. And just to follow up, so we use carbon as the same principle that you guys are doing, and I'll go straight to it. We're collecting gold and silver from carbon, right? Was that evaluated at some point that if your carbon can be used for a gold collector?
Yeah, we've talked lots, Tish in particular has thought lots about what do we do with the biochar? What do you do with this biocarbon? Who gets it? Who uses it for what? If it absorbs these metals like it does, and we know that it does at a greater rate than almost other materials, like activated carbon, right? You know what that does. Do we also talk about a recovery method to get the metals back out of the carbon and the char? Maybe. I don't know the answer to that, but somebody does, and we're going to make it possible for them to do it. We don't need to figure out exactly how to do it. We just need to make a machine that allows them to make a material from which they could recover metals. And so that's another research stream and a pathway, but I don't know the answer to the question yet of recovery. I know it's a key one. Could we go back to a mine and put this material in it and then take it back out? Probably eventually, but that's not a focus for us right away.
That was exactly the question I was going to ask. Can we use it for minerals recovery out of the tailings dam? So, but thinking the same. Can you talk about the yield? Like if I put 10 tons of organic material in, I get 10 tons of biochar coming out the other end, or do I lose things in the process?
Yes, you can talk about it. I will be imprecise in my answer only because my memory is terrible. We can, with the volume reduction from the original to this is not that significant. It's a little bit more than a ton goes in to get a little bit more than a ton out. But what's interesting is that the biochar itself, 1 ton of this is actually more than 2.5 tons of credit. So because it gets locked away for so long, you get a permanence variable, which makes it appear to be worth twice as much as it is on a cost basis. So yes, but also a little bit no.
All right, and one last question. So I'd never heard of biochar till about 2 years ago, and now everyone's talking about it. What happened? Because obviously the science has been around for a while, right?
Yeah, it has been around for 100 years. What happened was 2 things. One of them is I call it professionalization. So now it's not like a kiln in someone's backyard making charcoal. People have been doing this for a while, but what they do, and we still do it in the business, is take that biochar and burn it as a coal replacement. So that's kind of cool, and it's a CO2 sequestration sort of ish. But what happened was people realized that the biochar itself as a carbon sequestration component has a whole lot more value than it does as the biocarbon itself in use. So over the last sort of 5 years, people have started to try to figure out how to get ahead of carbon markets. And the voluntary carbon markets said, who's doing what at some scale that could scale up massively, because of course these people want 10,000, 50,000, 800,000 tons. And biochar production is the only one on the planet that's anywhere close to reaching them. enhanced weatherization, mineralization, CO2 changing in the rivers, stuff like that, nowhere near the magnitude that we need. This can be done everywhere in the world by all kinds of people and put huge dent in the CO2 that exists in our environment. Now, in this case, it's not in the atmosphere, it's in the plants, but it's already been locked up. So it's a combination of people realizing you can make money at it and then a concerted effort to professionalize it. But it's really been driven by those logos up there, Meta, Google, Shopify. All those people said, we're going to get ahead of this. We're going to inspire people to build this technology because we believe it's a great way in the future to do all kinds of good things.